Okay. Um, Before we get started on this problem here, I just want to point out that I hope that after you're done with this, you see why it is that you should perhaps take a look at these problems and think about them yourself before you watch my video. Because oftentimes, it wouldn't surprise me if you come up with a solution that is better than what I do, right? Because I don't always come up with the best solution. Now, I'm looking at this, I just look at this problem, the first thing that comes to my mind, that's what we're going to do, I'm going to run with it. And, sometimes later on, I might look back at it and say, oh, that really wasn't the best way to go about that. But then I don't change the video because I don't have time to make extra videos. So, but let's take a look here. In this problem, we got a point A, and we have point B. And we are trying to find a point P, X and Y coordinates for this point P, so that the angle of APB is a 90-degree angle. So I was kind of looking at this. I'm like, well, I think maybe P might be like over here might work somewhere. It looks like maybe a 90-degree angle. Maybe over here somewhere. It might be a 90-degree angle. Let's take a look here. I thought, well, you know what? I know about right angles. Right angles are if two segments meet at right angles, they're perpendicular. And if they're perpendicular, then their slopes are negative reciprocals. So let's see if we can't come up with a formula for the slope of some random point to A, slope of AP, and then another random formula for the slope, or another formula, not a random formula, another formula for the slope from B to P, right? So P has coordinates X, Y, and so the slope of A to P is going to be change in Y over change in X, or that's going to end up being 2 minus our unknown unknown Y coordinate over 3 minus our unknown X coordinate. Okay? So 2 minus Y over 3 minus X. And then over here, we're going to have, we're going to have 5 minus Y over 1 minus X. Okay? So let's see. And we know these slopes are going to be negative reciprocals, which means I'll take one of them and I'll flip it upside down and change its sign, and we'll get the other one. Right? So I'm going to set up an equation here using these two slopes. I'm going to say 2 minus X. Oh, why do I keep writing X? Oh my goodness. 2 minus Y over 3 minus X will equal, and when I flip these upside down, it's going to be 1 minus X and 5 minus Y, but I need to make that the opposite, right? So I'm going to put negative. Okay. Now when you take a negative here, I can actually just take the negative into either the numerator or the denominator. So I'm going to take the negative up into the numerator, and when I do that, I'll just change the signs of everything in the numerator. So 1 is going to become negative 1, and negative X will become positive X. So let's see here. That's going to give us 2 minus Y over 3 minus X equals X minus 1 over 5 minus Y. So let's see. Now we'll do a little cross multiplication. So I've got 3 minus X times X minus 1 equals 2 minus Y over 5 minus, or times 5 minus Y. Okay. So let's see, we'll multiply these together, we'll FOIL them together. All right, so that's going to give us, let's see, switch colors here again. Let's see, it's going to give us, a 3x, and positive x is going to be a 4x. And let's see, this is going to be a minus x squared. And then 3 negative is going to be a minus 3. Right? And then, see over here, it's going to get, let's see, a negative 5y and a negative 2y. That's going to be negative 7y. And let's see, I'm going to have a positive y squared. And 2 times 5 is going to be a positive 10. So I end up with this equation here, which my first thought about that was like, if I just graph this one I don't know. So I thought, well, okay. So an equation describes a set of points. So there are some x, y values that'll make this equation true. So there's some numbers that I could plug in here, and I will get a true statement. And some numbers I'll plug in that I'll get a false statement, right? And oddly enough, at this point, we're just going to test that out. Okay, we're going to test that out real quick. I'm going to plug in x equals 1 and y equals 5. Okay, so let's see. It's 4 times 1 squared minus 3, negative 7 times 5 plus 5 squared plus 10. So that's 4 times 1 is 4, minus 1 is 3, minus 3 is 0. And see, this is going to be 35, negative 35 plus 25. Oh, what? 25 and 10, that's 35, and that adds up to 0 too. So interestingly enough, x equals 1 and y equals 5 makes that equation true. And over here, that's our point B. So you're telling me that if P is directly on top of point B, I get a 90-degree angle? Something's odd there. Anyways, I want to see, well, what do all of the points look like? I mean, if I get a graph of what all the points look like that make that true. So I went over to my handy-dandy graphing utility here. Let's take a look. Here it is. Okay. And I just plugged the equation in, and it did some simplifying for me here. And turns out it's a circle, right? So every point on this circle could be a point P. So if I could, any point on this circle, and actually I can go ahead and I'm going to place a point on the circle right there. And I'm going to measure the angle. Let's see, let's go measure the angle. And let's put in a couple little segments here just to kind of make this look nice. Okay. And then I'm going to add a little thing here about let's go to my settings. I want this to be a angle between 0 and 180. Okay. So there's a point, right? And notice I move this around the circle and it's always 90 degrees. So point P could be anywhere on this circle. Anywhere on this circle at all. Okay. And we always get a 90-degree angle. That seems kind of interesting. And that reminded me of a couple of theorems here. And that is, well, that you can take any right triangle and you can always put it inside a circle like this. Or that if you have a circle, and this is the diameter of the circle, right? This segment from A to B is the diameter of the circle. And let's put, there would be the center of the circle, right here at D. So as long as if I've got two points, and I find the midpoint, I have the center of the circle with right there, and the circle is going to go through both those 2 points, that any point on the circle will make a 90-degree angle. Right? I'll have a right triangle. And there's a lot of information packed in there, and a lot of stuff to think about, different conclusions that we can draw from this. And then also the question of, in general, how do we know that that's true? Is there anything more to that? So it's definitely something to look into later. Yeah, I think that's definitely kind of interesting. So P could be anywhere in there. So if I wanted to show all the possible points for P, I would have to find a way of describing this circle. So let's go back and do that real quick. Okay. So the equation, the formula for a circle is, let's see, x minus h squared plus y minus k squared equals r squared, where r is the radius and hk is the center. Okay. So the center of this circle is going to be the midpoint, which we can find using midpoint formula, or I can go here, it's 1, 2, and 1, 2, 3.5. Okay, I just plug those in. So let's see, we've got x minus 2 squared plus y minus, let's see, 3.5 squared. And then the radius of our circle here is just the distance. So that's the distance from the center to the edge, and that's going to be 1.5 and 1. So I do our Pythagorean theorem here. 1.5 squared plus 1 squared is c squared. Let's see, that's 2.25 plus 1 is c squared. So it's 3.25 equals c squared. And actually at this point we can stop because we don't want c, we want c, we want the radius squared. So we can just put in 3.25. So now we've described every point that makes, on that circle, every point that P could possibly be. We'll have x and y coordinates that make that equation true. Which, by the way, that's the same equation as down here, just in a simplified form. Yeah. Then I thought, you know what? I wonder if there's any other, like, because I mean, obviously that circle has lots of, like, you know, maybe fraction or irrational coordinates, you know, numbers that we really have, just ugly looking numbers on it, but maybe it's got some whole number coordinates on it, right? So let's go back and take a look. Like, if we look at that circle, are there any other, like, just plain whole number coordinates, right, that I could pick for P? And then I looked at it, I'm like, well, you know, right here, there's one at 1, 2. I can go over here, and there's another one over here at 3, 5. Now I look back at my original problem again, here, and I think, oh, if I want to put point P at a place that'll make this a right angle, just go right here at 1, 2, right? Just make a right triangle there, or I go up here at 3, 5. Like two very obvious answers that I just didn't notice when I started, and I went on this whole journey here to get to something that was, you know, fairly obvious. But that thing with the circle, that's definitely interesting and definitely something that we should be looking into later. And I hope that you were able to follow these calculations, because it's definitely worthwhile. Who knows? Maybe that'll show up on a quiz later.